Assalamualaikum. My name is Sufi Huzaimi bin Muhammad FAUZI and my supervisor is Technologist Dr. Nasrul Fikri bin Cekpa. My project's title is Development of Xylanase Enzyme from wheat bran for bleaching bamboo fiber processing with assisted power ultrasonic. For Chapter 1, I will explain the project background, problem statement, objective, and scope of study. In the process of effective dyeing for all natural fibers, it must reduce or eliminate the yellowness of the fiber. Hot alkaline hydrogen peroxide is one of the oxidative bleaching which is most popular method used in bleaching the cellulosic fibers. Nonetheless, significant fiber rupture will be resulted from this chemical bleaching method. Another conventional bleaching method is chlorine as oxidizing agent. This chemical bleaching method will produce huge amount of toxic and hazardous pollutant toward environment which goes to the soil and water bodies as effluent. The effective method for bio-bleaching is the removal of lignin and hemicellulose present in wood. Xylanase enzymes are usually used as pre-treatment for bleaching to enhance the effect of bleaching using chemical bleaching agent to minimize the release of chemicals. In research, Xylanase enzyme can oxidize lignin depending on enzyme concentration, pH, temperature, and time to brighten the pulp. The Xylanase enzyme can be produced in higher level when using cost-effective agro waste, which is wheat bran as substrate in solid-state fermentation. The application of ultrasonic energy will lowering the time process, energy, chemical use, and improving quality of product. The ultrasonic frequency range is higher than 16 kHz, which will perform heat transfer in liquids, and the ultrasound-induced cavitation will generate bubbles for cleaning purposes. Morphological changes in fibers will be produced by ultrasonification to increase flexibility and enhance the fibers bonding in the process of paper formation and efficient bleaching of pulp. Ultrasonic wave treatment have been reported can enhancing the tensile strength and brightness properties of recycled pulp fibers. The problem statement is, in the textile and papermaking industry, their effluent is known to be toxic and hazardous to environment because of their releasing of chlorinated organic substance in the bleaching of natural fibers used. Effluent produced during chemical bleaching contain a lot of carcinogen substance which will affect the human being. There has some research found by using Xylanase enzyme as pre-treatment before addition of hydrogen peroxide will lowering the chemical substance released as effluent compared to using only hydrogen peroxide as bleaching agent. Nevertheless, it will still lowering a bit the bamboo fiber strength and having some chemical release to environment. For the objective, first one, to synthesize Xylanase enzyme from wheat bran. The second, to study the properties of Xylanase enzyme via changes of color in spectrophotometer. Third one, to study the effect of Xylanase enzyme sonic assisted bleaching process. And the last one, to analyze the tensile strength of bamboo fiber after the process. The scope of study is solid-state fermentation was carried out using wheat bran as the substrate with 10 grams of wheat bran and mixed with 30 ml of mineral salt. Then, for the pre-treatment of the bamboo fiber, equivalent to 20 grams oven dried taken in polyethylene bags were charged with Xylanase under specific condition. The mixture of bamboo fiber and Xylanase enzyme sample is sonicated continuously at sonic power ranging from 60 to 300 watt and ultrasound frequency is 25 kHz for 1 hour at different pH, enzyme dose, and temperature. For the testing method, tensile strength was measured according to ASTM and brightness of the fiber according to type test method T5 to 5 ohm 12. For Chapter 2, I will explain those subtopics shown in slide. Bamboo is largely composed of cellulose, hemicellulose, and lignin, with cellulose accounting for around 60% of the total and lignin accounting for around 32%. Based on research, bamboo fiber contains a lot of lignin and hemicellulose which bind to the bamboo fiber closely without a space. As a result, microbial mycelium and lignin degrading enzyme have a hard time penetrating into the center of bamboo, making bamboo fiber extraction more challenging. Bundle of fibers are fabricated of sclerenchyma cells and perform as bamboo reinforcement that give higher tensile strength compared to some fibers of synthetic and metallic. The application of bamboo fiber are widely used in food and feedstock industry, textile industry, and pulp and paper industry. Bleaching refers to the use of chemical agent to brighten woods. The powerful chemical employed in bleaching chemical pulp shortens cellulose molecules, making fibers weaker. Oxidizing bleaching agent like hydrogen peroxide and chlorine-based bleach commonly used to bleach the fiber. Bleaching process having purpose of eliminating any residual lignin that may have remained in the pulp after the pulping process and to advance the pulp brightness to a desirable level. Chemicals used in bleaching produce a variety of toxic products, which is harmful to the environment. Previous research has shown that hydrogen peroxide is the most promising total free of chlorine bleaching agent due to its easier use and environmental friendly. However, hydrogen peroxide bleaching conventional method is carried out at high temperature and near boiling point of water and needed pH 10.5 to 12, which is high alkalinity. This results in higher energy consumption and greatly reduce the cellulose strength. For the Xylanase enzyme, the most major sources used in the production of enzyme are fungi and bacteria. Bacillus genus is the well-known bacteria used. Xylanases are useful for various applications based on their different characteristics. Bacillus species can adapt at high temperature and high pH that lead to higher Xylanase activity. This type of Xylanase are widely used in industrial application because of their ability. Due to high production, extracellular enzyme release and higher enzyme activity as compared to bacteria or yeast, fungal type Xylanases are important too. Nevertheless, it is not suitable in industrial application. It is efficient at low temperature, which is 50 degrees Celsius, and range of pH at 4 to 6. Thus, this type of Xylanase are not suitable in paper making industry that need high alkalinity and high temperature. Furthermore, due to the longer generation time and co-production of a highly viscous polymer that reduces oxygen transmission, large-scale production of fungal Xylanase is become problematic. Now, I will explain about factors affecting of Xylanase enzyme production. Two parameters that influence the production of Xylanase, which are physical and nutritional parameters. Firstly, temperature, pH, duration of incubation, size of inoculum and agitation are type of physical parameters, while for the nutritional parameters including nitrogen, carbon source, vitamins and trace elements in fermentation. The carbon source, for example, is cheap agricultural waste, which is wheat bran. There are two types of fermentation, which are submerged fermentation and solid state fermentation. Submerged fermentation is advantageous for production of Xylanase using either bacteria or fungi, but Xylanases have been investigated extensively in submerged culture procedure too far. But the comparatively high cost of enzyme production and the more energy intensive process have limited their practical applicability. Solid state fermentation is a standout approach for Xylanase synthesis, particularly in fungal cultivations, because it offers numerous benefits, including higher productivity per reactor volume and cheaper operating and capital costs. Ultrasound is referred to sonic waves that have higher frequency than what human can hear. Physical and chemical processes plays a role of power ultrasound potential. Chemical processes are chemical effect generated by ultrasonic cavitation in liquid, whereas physical processes are mechanical impact of high intensity wave in a medium. In biobleaching industries, ultrasonic energy can be used to intensify enzymatic treatment of natural fiber, which will enhancing the enzyme molecule transportation to the surface of fiber. Cavitation bubbles will generate shock wave, lead to collapsing of bubbles with the fiber surface, creating a perfect mechanism of stirring for creation of enzyme took place at the layer of liquid at the solid liquid interface. Sonication can significantly boost the bulky enzyme transportation towards the fiber surface by the agitation of the liquid body layer, which resulting in an improvement on the overall reaction rate. For chapter 3, I will explain those subtopics shown on slide. For production method of Xylanase enzyme, Bacillus pumilus species microbial strain was our own isolated. Stock culture were being maintained on nutrient agar containing peptone, beef extract and agar. Preparation of inoculum are in 250 ml Erlenmeyer flask containing peptone and mixture of beef extract with distilled water and inoculated and incubated. In the production method, 10 grams of wheat bran will be mixed with 30 ml of mineral salt in 3 Erlenmeyer flasks and incubated for 48 hours. Then, the content is squeezed through muslin cloth and centrifuged for 30 minutes at 4 degrees Celsius. For enzyme assay, the amount of reducing sugar, xylose equivalent liberated for xylan was measured using 3,5-D-nitrosalicylic acid to determine the activity of Xylanase. In a spectrophotometer, the absorbance of the generated color was compared to a control at 450 40 nanometer. Under specific condition, amount of enzyme catalyze the releasing of 1 micromole of reducing sugar as xylose per minute represent 1 unit IU of Xylanase. Next, for pre-treatment bamboo fiber step, 20 grams of bamboo fiber was cooked at 180 degrees Celsius for 60 minutes and bamboo fiber was pre-treated with 10 IU per gram of Xylanase in polyethylene bag under optimal conditions. Then wash the bamboo fiber with 75 mesh script. Bamboo fiber was immersed with different enzyme concentration 20, 30 and 40 IU per gram Xylanase in a bath at different temperature 40, 50 and 60 degrees Celsius and different pH 9, 10 and 11. The bath was sonicated for 1 hour using sonic power ranging from 60 to 300 watt. The frequency of the ultrasound was set up to 26 kHz. For the testing method, tensile strength was measured according to ASTM and brightness of the fiber according to Tapi test method. In chapter 4, I will explain about the expected result. The expectation is Xylanase enzyme can be used as bleaching agent to brighten the fiber because the material used to produce this type of enzyme is cheap, which is from agro residue with BRAN. Xylanase enzyme can reduce lignin content in the fiber, where can reduce the yellowness of the fiber. Furthermore, in this study also will determine the efficiency of bleaching in the ultrasonic. It is expected will enhance bleaching of bamboo fiber by reducing the process time. It is also expected the bamboo fiber can get better brightness and enhance the tensile strength compared to conventional method. For chapter 5, I will explain the conclusion. In conclusion, Xylanase can be produced in high yield by using wheat bran under solid state fermentation. In a research state that Xylanase enzyme can oxidize lignin depending on enzyme concentration, pH, temperature, and time to brighten the pulp. Furthermore, with the ultrasonic assisted in bleaching can enhance the brightness of the fiber by reducing the enzyme concentration, time, pH, and temperature. So this is my Gantt chart for this FYP1. So that's all from me. Thank you.